We'll talk about how to multiply polynomials. A couple reminders. The exponential rules for products is a to the n plus a to the m is a to the n plus m. The distributive property of a times the quantity b plus c is a times b plus a times c. When multiplying monomials, we're going to use the exponential rule for product. Example number 1. We want to multiply 4x cubed times 5x squared. The solution of that is you can do 4 times 5, which is 20. And x cubed times x to the 7th is x to the 10th. Part B, we want to multiply 2 times a cubed plus b to the 4th times the monomial 6 times a squared plus b to the 5th. So that's equal to 2 times 6 is 12. A cubed times a squared, again, add those exponents, you're going to get a to the 5th. B to the 4th times b to the 5th is going to be b to the 9th. Multiplying a polynomial by a monomial, we're going to use the distributive property. In example number 2, we're going to multiply 5x to the 4th, which is a monomial because there's one term, times 3x cubed plus 6y to the cubed. It's a polynomial because it has more than one term. They're all polynomials, but it's just a way to think of it. The solution to this is we're going to go ahead and distribute first. We're going to have 5x to the 4th times 3x cubed plus 5x to the 4th times 6y cubed. Then 5 times 3 is 15. X to the 4th times x cubed is x to the 7th. 5x to the 4th times 6y cubed is going to be 30 x to the 4th y cubed. Part B, we want to multiply 2a cubed b to the 4th times 6a squared b to the 5th minus 4a cubed b cubed. Again, distribute first. 2a cubed b to the 4th times 6a squared b to the 5th minus 2a cubed b to the 4th times 4a cubed b to the cubed. 2 times 6 is 12. A cubed times a squared is a to the 5th. B to the 5th times b to the 4th times b to the 5th is b to the 9th. 2 times 4 is 8. A cubed times a cubed is a to the 6th. B to the 4th times b cubed is b to the 7th. Multiplying binomials by binomials, you can use the distributive property. So binomial means two terms, bi meaning two. So we want to multiply 3x plus 2 times 4x minus 5. So we're going to distribute 3x times the 4x minus 5 plus the 2 times the 4x minus 5. Just distributing this first one through to both things. Then distribute again, 3x times 4x minus 3x times 5 plus 2 times 4x plus, minus 2 times 5. So that gives you 12x squared minus 15x plus 8x minus 10. And then collect like terms, gives you 12x squared minus 7x minus 10. When multiplying a binomial by a binomial, one can use a way to remember what the product would be. Notice in the previous example, the first term is the product of the first two terms of each binomial, 3x times 4x. The second term is the product of the outer terms of each binomial, 3x times negative 5. The third term is the product of the two inner terms, 2 times 4x. The final term is the product of the last terms of each binomial, 2 times negative 5. The mnemonic for this is FOIL, where for F stands for the first term in each binomial, O stands for the outer term of the two binomials next to each other, I stands for the two inner terms of the product, and L stands for the last terms of the two binomials. You don't need to use the FOIL mnemonic devices unless you want to use it. Next example will show using this mnemonic. So this time, in example 4, we want to multiply 3x plus 5 times 4x plus 9. So the FOIL first term, F will be 3x times 4x. First outer, the O stands for the outer, and that's going to be the 3x times the 9. The I stands for the inner two, which will be the 5 times 4x. And then the L stands for the last, and that will be 5 times 9. So what you will get when you want to multiply these out is 3x plus 5 times 4x plus 9 is going to be 3x times 4x plus 3x times 9 plus 5 times 4x plus 5 times 9. FOIL. Which gets you 12x squared plus 27x plus 20x plus 45, which is going to equal 12x squared plus 47x plus 45. Example number 5, let's multiply out 6x minus 3 times 4x plus 1, again using the FOIL method. So it's going to be 6x times 4x, that's your first, plus 6x times 1, that's your outer, plus negative 3 times 4x, that's your inner, plus negative 3 times 1, that's your outer, your last. So that gives you 24x squared plus 6x minus 12x minus 3, which is 24x squared minus 6x minus 3. Multiplying a polynomial by a polynomial. When multiplying a polynomial by a polynomial, one cannot use FOIL. It's just using the distributive property. So example number 6, I want to multiply 3x plus 2 times 4x squared minus 3x plus 1. So this is going to be 3x times 4x squared plus 3x times negative 3x plus 3x times 1 plus 2 times 4x squared plus 2 times negative 3x plus 2 times 1. That's going to give you 12x cubed minus 9x squared plus 3x plus 8x squared minus 6x plus 2. Collecting like terms gives you 12x cubed minus x squared minus 3x plus 2. Multiplying 5x to the squared plus 7a plus 2 times 8a squared minus 3a plus 1. That'll be 5a squared times 8a squared plus 5a squared times negative 3a plus 5a squared times 1 plus 7a times 8a squared plus 7a times negative 3a plus 7a times negative 1, and I'm sorry, that was a negative 1 up there, apologize, plus 2 times 8a squared plus 2 times negative 3a plus 2 times negative 1. Now just multiply out and collect like terms. So you get 40 a to the 4th minus 15a cubed minus 5a squared plus 56a cubed minus 21a squared minus 7a plus 16a squared minus 6a minus 2. Collecting like terms gives you 40a to the 4th plus 9a cubed minus 10a squared minus 13a minus 2. Special products. There are some products that are quicker to compute if one notices a quick formula to use. One doesn't need to use these if you don't want to, but if one notices the form, it makes them faster. One can only use these special products if you notice the formula. Otherwise, you need to follow the normal processes. Here are the formulas. The conjugate product, which is also sometimes known as the difference of squares, is a plus b times a minus b, which is going to multiply as a squared minus b squared. Binomial square, or also sometimes known as the perfect squares, if you have a plus b quantity being squared, you're going to get a squared plus 2ab plus b squared. Or if you have a minus b squared, you're going to get a squared minus 2ab plus b squared. We want to multiply out 5y plus 7 equals 2. This is the binomial square formula, and you need to figure out what expression is a and what expression is b. In this example, a is equal to 5y and b is equal to 7. So just replace the values into the formula. So this will equal a squared, 5y squared, plus 2 times 5y times 7, a times b, plus 7 squared or b squared. That will give you 25y squared plus 70y plus 49. Another one is if I want to multiply 6w minus 4z times 6w plus 4z. This looks like the conjugate pairs formula, where a is equal to 6w and b is equal to 4z. This will multiply out as the A 6W squared minus the B of 47 squared. Oh, sorry, not 47, 4Z squared. That gives you 36W squared minus 16Z squared. Again, you can just multiply these out, though realize that the square means that you are multiplying the expression by itself. So think about what that is, but you can do them other ways. One more example is multiply out 8n minus 6p squared. Again, this is the binomial square formula. You just need again to figure out what a and b are. In this example, a is equal to 8n and b is equal to 6p. So this will multiply out as 8n squared minus, because the minus sign there, 2 times 8n times 6p, 2 times 8 times b, plus 6p quantity squared. That's 64n squared minus 96n times p plus 36p squared.